So I'm the Mackenzie Cloud Solution Architect at Microsoft. Basically means I work with a small number of customers and ensure they have a good experience when using the Microsoft Azure Cloud. And tonight I'm going to talk about Service Fabric, which is a Microsoft, it's not really a product, but it's a free service to help other people to run microservices, pretty much for everybody. So, a few years ago, Microsoft, one of the teams at Microsoft, 6-7 years ago, realized they needed to sort of come up with a new way of running services at scale with state stored. So they started working on it, and they came up with this service called Service Fabric, and their team has used it for 4 or 5 years in production. And many other teams at Microsoft have started doing it. And it's really to do with a number of problems that we're sort of working in the cloud, especially sort of fragility of the underlying hardware and the software it runs on. So Azure Service Fabric is a hosting platform for microservices. It runs anywhere. You can run on the laptop, you can run in any cloud. Microsoft demonstrated it running AWS at its Build conference a few months ago. And it's 2 years of supported service. So it's basically been running for a long time in production on Microsoft, and actually other customers are using it as well. So it's running some of the Azure cloud infrastructure runs using Service Fabric. It's not the whole thing doesn't run in Service Fabric, it's certain bits that are used Service Fabric. The SQL database team came up with Service Fabric, and they run 1.5 million databases as a microservices deployment on top of Service Fabric. And then down the bottom, other Azure services that are using it. So I'm going to try and do a demo here with one hand.
Do you want this also available on
Can you hear me now? So I didn't want to partial slides over me first. So what I'm going to do is create a cluster Service Fabric cluster in Azure. So one of the things Microsoft has with Azure is we have a templating language. You can define the properties of your service using templates. And so this is an example of a template. I'm not going to walk through it, but it's just a JSON description of the services. In this particular case, it defines the VNet, multiple storage accounts, and then the properties deploy. Essentially, deploying a cluster of 5 VMs, and then Service Fabric sitting on top of these VMs. So it's really just a relatively, it's got a schema, etc., for all the different types of services. This is the one in front of the load balancer. But it's a way people at Microsoft are deploying these services is using these templates. And then with a template, you can then use, in this example, PowerShell, or you can use REST API, or you can use the Azure CLI that runs on Linux or on the Mac to just deploy a template. And in this particular case, I'm deploying a template, I have to give a parameter file, let's say you've got usernames and passwords or whatever. I can parameters the deployment, and then I just look, and then a file with a template file. So this one command is a parameter file and a template file. I'm just going to basically execute that. And in about 5 minutes, I will have a Service Fabric cluster completely defined with Service Fabric running and 5 new VMs somewhere in Azure Data Center in West.US. So I'm just going to leave that run. It takes about 5 minutes for the whole thing to come up. I'll go back to showing slides. So the challenge for microservices are A, a hosting environment where you're going to host your microservices, and scheduling the service into that hosting cluster. Things like service discovery, how does service A on node 1 know where service B is on node 5, which has just died on here. So things like health monitoring becomes important to understand to sort of deal with that situation. And then it's automating deployment as much as possible. So let's say if I add an extra node to the cluster, Service Fabric or whatever will automatically be deployed in it, the cluster can rebalance, all that kind of stuff. So a Service Fabric cluster, which is the deployment of, it's what Service Fabric is deployed. It's really a set of compute nodes. You can have multiple different types of compute nodes in the cluster. It runs Windows because it was originally developed for Windows, and over the last 6 months it's been a preview of Linux, and also the ability to run containers on Linux available. So the Linux one just runs a single node cluster at this point in time, but anyone can run it and deploy one the other day just to try it out. I'm more of a Windows person, so I haven't really deep into it. But there's a lot of work, probably the major work in the Service Fabric team there is a Linux port. You can deploy it anywhere, it runs on my laptop, runs in the cloud, etc. And the cluster contains various management services to sort of manage the cluster itself and the services deployed into it. So the deployment model is you deploy applications. So the single cluster can contain many applications. It supports versioning, so the same application will be deployed multiple times in different versions. And an application is a collection of services. And then you can do an application through an isolation unit for, that's why I said you can have application 1 with one version, application 1 with a different version, and then isolate from each other. The services are sort of independently deployable pieces of software, more or less like a traditional service. And the interface to the platform is relatively simple. It's more or less just you can provide a run command or something like that. And the Service Fabric will run that service and manage the health of it, etc. Services can have endpoints declared that the cluster can know about and manage. And then they also have configuration files. So it's typically 3 files defined what a Service Fabric deployment is. There's the application, there's the cluster manifest of the cluster itself, then there's the application configuration, and then there's the service configuration. And each of these are independently changeable. So if you need to upgrade the configuration of the service, you can just change the configuration. You don't need to redeploy the service. And similarly with the application, you can do that. So the programming model is as follows. So there's 2 different native types of application for reliable service and reliable actors. Reliable services come in 2 forms. They can be stateful or stateless. The service was originally developed by the SQL database team, so they're very interested in reliable state. So the idea of the reliable state is the state is actually stored on the local compute node. It is not stored off the compute node, so it avoids things like latency going to third-party services. Although you can obviously connect to external services if you want. But a lot of effort was made to develop a local state that you could store in a reliable stateful service. They also support replicas for scale out and partition. So replicas for high availability and partitions for scale out. So the services are, you can define a stateful service will have multiple partitions and have them distributed. With reliable services and reliable actors, you get native integration, so the platform can look into what's happening in the service, and the service can look into what's happening in the platform, and they can sort of interact in a nice and friendly way. The reliable actor model is based on the Orleans actor model coming out of Microsoft research that was used for the Halo 4 game. We used a part of that for some of the services. It again provides sort of stateful actors. They're virtual actors, so you can create, the way Halo worked was they created, every user in every game had an actor they created for it, and then once the game stopped, you would kind of just drag and select the actor and leave it on disk. But if you ever want to go back and look at what happened to the actor, you could resurrect the actor, rehydrate it, and bring it back up. So you can think of it as a really good way for doing intelligent caching. It's a very common model for that. So it's reliable actors for Service Fabric pretty much took the Orleans model, made it in a form that was productizable and kind of supportable, and sort of worked for a broad spectrum of developers. The Orleans framework is still out there, it's very heavily supported OSS framework. It's very popular one, but reliable actors and Service Fabric is just what it's essentially supported version of that. Then you can run any executable you like as a guest executable. You won't get the deep platform integration, but you can get the benefit of the orchestration layers in terms of making sure everything's running healthily. And that's the guest executables, the way that the Linux support is currently being done. Things like Java executables and Node.js executables are running them. So the local state is used by stateful service and reliable active user. It provides two different types of state. Dictionaries, which is just name value pairs, and queues, just a local, fairly simple first in, first out queue. They're partitioned for scale, and it kind of uses a similar model to the Dynamo and Cassandra model of multiple partitions and multiple replicas in these partitions. So you may have an application with 100 partitions. A service you may declare a service of 100 partitions. Each of these partitions may be in 5 replicas. It uses an active passive model, so all the writes are done to a primary, and then there's say 2 or 4 sort of passive secondaries, and they will get the data with a sort of core commit nature. So you won't get a response until it's committed in at least a core of the replicas. And if something happens to the primary for some reason, the node dies or is being upgraded, one of the secondaries will be promoted to primary, and a second copy, another copy will read without the replica. So all this is fully automatic. You don't have to do any of that work yourself. The Service Fabric handles the distribution of the data among the nodes that is failed detected. It also supports transactions inside the partition. So the scheduling algorithm for Service Fabric is essentially a monolithic scheduler. It's a complete view of the cluster. You can then these days there's node constraints on the actual compute, and some of them are coming from the way Azure works, and then Azure's got the concept of fault domains, which you can think of as being like a rack. So if we put 2 services in different fault domains, they'll be essentially different racks to get a greater sense, greater high availability. We also upgrade domains. When the system does upgrades or your application is upgraded, you will do upgrade domain 0, and all the nodes in upgrade domain 0 are upgraded, then they'll move to upgrade domain 1. So we kind of march through or walk through the upgrade domains doing either your application upgrade or say an underlying host upgrade. And as it's doing that, if it fails, it will roll back automatically, and you should hopefully be in a better place. The platform itself continually monitors. It's like, I think every 10th of a second it checks the state of the platform to make sure the cluster's running, and pretty much every second it will try and rebalance the cluster if necessary. If it detects there's some need to balance it, there's various rules that you can sort of modify using placement and capacity constraints. You can say this service needs a lot of memory, so kind of only move it to a node with this much free memory, etc. You can change some of these constraints. The placement and capacity constraints are essentially name value pairs that you define and you control, and the platform knows about them, and then you can change them dynamically and alter the balancing of the nodes. So you may want the default allocation if you deploy a service with multiple replicas, multiple partitions with replicas, it'll try and spread the primary replicas across all the nodes, distribute them evenly across the nodes. But and then if you kill a node, it will kind of rebalance the partitions across the nodes. If you add a new one, it will spread the partitions across the new nodes automatically. But you may have circumstances which you may want to actually bunch the nodes up, bunch the existing partitions up into a smaller number of nodes, because you want to keep some of the nodes free, and you can do that. So you have a lot of capability of what you can do. There's things like affinity and anti-affinity of node placement, of service placement, sorry. So you have a lot of flexibility there. By default, Service Fabric uses ETW, which is a deep Windows kernel logging system, and so the Service Fabric as a platform uses that, so you can start seeing Linux monitoring, and the default Windows.NET environment uses the same thing, but you can use any logging you like. At the end of the day, these are just, Service Fabric just sits in raw VMs, there's nothing special about them. It's running Linux, it's like the Ubuntu image, running Windows, it's Windows Server, whatever, and you have access to these nodes, you can do whatever logging Fabric you would like on it. Obviously, the platform keeps pretty close view of the health of the cluster, the health of the application, the health of the services running on it, and these kind of spin up. And if the cluster detects the service is going bad, it'll kind of notify the application that things are not going well with the service. They kill the service and move it to somewhere else. I mentioned earlier the rolling upgrades scenario. Here's a sort of example with just 6 nodes, and it's got 2 fault domains horizontally, and then 3 upgrade domains vertically. And if you start a rolling upgrade with service 1, you can see here upgrade domain 0 has been upgraded to V2, whereas the other upgrade domain 1 and 2 are still left on V1. And you can see that the nodes, the services are just distributed also randomly across the nodes. So I've got another demo. I didn't want to be doing this to PowerPoint all the time, so hopefully. So I actually have a cluster running locally in this box on my laptop. So you can see this cluster's got 5 nodes. So it's essentially exactly the same software running on my laptop that runs in Azure in the Service Fabric cluster, or runs in your data center, or runs in Google or whatever, wherever you like. So this one's got 5 nodes running. You can see down here it's got various managed services running. And it's got 2 applications. I've pre-deployed 2 applications. One of them is a word count application. It's pretty simple. It comprises 2 services. There's a front-end web service and a back-end service to store the state. So these are just demonstration applications. And then this other one is a cluster monitor application. It's just essentially a single thing. It's running as a single replica. So this is running on node 3 down here. And you can actually see cluster monitor application is this one. So it just shows you what's happening inside the cluster. So node 3 is the one where the cluster monitor application is running. You can see here a couple of primaries over here, a couple of primaries here. And so the primaries are distributed. So this one, I think the word count is good. Each partition is just 2 letters of the alphabet. So it's like, it's not as numbers, it's 1 to 2, 3 to 4, etc. for each partition. So there's 13 partitions, which you use 2 letters per number. And so if I look at, say, this guy here has got 3 primaries on it, so it's node 1. I can go back over and I can go back to my Service Explorer. So I can go back to my Service Explorer and look at node 1. So you can see the same information here. The monitor application is just doing the same, showing the same thing. Okay, node 1 is the one I'm after. So node 1's got 3 primaries on it. So I'm going to take node 1, which has got 2 services down here. And then sort of drill into the instances that it's running here. So you see it's got 2 primaries there. But what I'm going to do is I'm going to kill it. So it's going to ask me to, I think it's underscore 1. So I'm deactivating that node. So the whole system just dies. So node 1 is about to die. There's to come down. But there's some secondaries and the other nodes have been promoted to primaries. So the primaries have been redistributed over the other nodes as that one went down. So it's now nothing running in node 1. And I can bring it back up. And it's starting to come back up now. So you can see it automatically distributed the primaries off the existing nodes by promoting secondaries, and now it's sort of reloaded secondaries off onto node 1, the one that failed. So this can all happen automatically. Can happen at scale. Microsoft's got very large services running exactly this technology right now. The Word one was just pretty simple. You can see here's my partitions. I've got my 13 partitions from different letters of the alphabet. This has been running since there's one word, generates 1 word a second. This has been running since sometime this afternoon. I shut the laptop off a couple of times, and because the state's preserved, it's brought it back up and kept going where it was before. The other demos I want to do was, so earlier on I created a Service Fabric cluster manager. Hopefully it's completed by now. So that deployment, the single command with that template created a VNet, subnet, multiple storage accounts, 5 VMs, and deployed Service Fabric on each of the VMs. So this Service Fabric cluster is currently ready. So it's based on upgrade. You can see it's all green here, and the status is upgrade. So what I'm going to do now is actually deploy an application to it, deploy the word count application to it. So I'm just going to sort of save a few variables, like where's the location of my application path, etc. What's the application type? I'm just going to run some of these. The next step I have to do in this case is I'm going to connect to my Azure Service Fabric cluster. I'm using credentials for authentication. Make this bigger. So I've connected to my cluster. And now I'm going to upload the application. The application is just literally as a directory. See it here. I'm just going to point to this word count directory. And then there's 2 packages for the services underneath it. The code, etc. is under here. So there's nothing special. I haven't done any special wrapping. Obviously there's a special directory structure, but there's nothing special about the application. So I'm just going to upload it to my image store in Azure, in my cluster. And that should be pretty quick. Then I'm going to register the application in the cluster. And now I'm going to deploy an application. I'm going to deploy the application into the cluster. If I go to the portal, this is the Azure portal right now, there are no applications deployed. And once I do this step, the application should be deployed pretty quickly because the application's in the cluster already at this point. So that's the application configured. I'll refresh, hopefully it will show the application is there. Okay, so there's the application is now deployed into the cluster. So it's the same application I had before. It's got a slightly different configuration. And if I try and find it, this is this guy here. So that didn't work because the link, I just created a brand new cluster. This is an old link. Hopefully that's right. This is going to work. So that's me. So during in the 15 minutes or whatever I've been talking, I've completely created a Service Fabric cluster in Azure, deployed an application into Azure from scratch, with basically about 6 active lines of code. So you can see the benefit of running some infrastructure code. This is like the 6th or 7th cluster I run today. My friends up the back have been watching me all day, so deploying clusters makes it so easy to do. Once we're using this templating and kind of just using PowerShell or the Azure CLI to do it. So this is the difference between this one and the other one. This one's only 2 partitions. The other one's got 1 to 13 and 14 to 20. Others is exactly the same application. So if we look at go back to look at this Service Fabric Explorer, you can start to see some of the configurations. So up here, you can see the cluster configuration. So this kind of shows you the cluster configurations. So we make it bigger. So this is the cluster configuration. Typically, people aren't touching that unless you're developing, deploying their own clusters or doing tweaks like changing the constraints and stuff like that in the cluster. But you can see this is one of the nodes, and in this case, all the nodes are identical. The port numbers might be different because I'm hosting it all locally. And then like this application, the cluster monitor application, and it has got a similar, if I can see the manifest defining the config file defining it. It's kind of like this. It's a fairly simple XML file defining. You can see this one's got a stateless service. And if I look at the other one, this is a stateful service here. So look at the manifest for this one. You can see the exe, when it said you can run any exe, pretty much it's just that line there. But if I put Node.js, they would be running Node.js right now. And that wasn't what I wanted. I wanted this manifest here. So this is the application. So during in the 15 minutes, whatever I've been talking, I've completely created a Service Fabric cluster in Azure, deployed an application into Azure from scratch, with basically about 6 active lines of code. So you can see the benefit of running some infrastructure code. This is like the 6th to 7th cluster I run today. My friends up the back been watching me all day, so deploying clusters makes it so easy to do. Once we're using this templating and kind of just using PowerShell or the Azure CLI to do it. So this is the difference between this one and the other one. This one's only got 2 partitions. The other's got 1 to 13 and 14. But others is exactly the same application. So if we look at go back to look at this Service Fabric Explorer, you can start to see some of the configurations. So up here, you can see the cluster configuration. So this kind of shows you the cluster configurations. So this is the cluster configuration. Typically, people aren't touching that unless you're developing, deploying their own clusters or doing tweaks like changing the constraints and stuff like that in the cluster. But you can see this is one of the nodes, and in this case, all the nodes are identical. The port numbers might be different because I'm hosting it all locally. And then like this application, the cluster monitor application, and it has got a similar, but you see the manifest defining the config file defining it. It's kind of like this. It's a fairly simple XML file defining. You can see this one's got a stateless service. And if I look at the other one, this is a stateful service here. So look at the manifest for this one. You can see the exe, when it said you can run any exe, pretty much it's just that line there. But if I put Node.js, they would be running Node.js right now. And that wasn't what I wanted. I wanted this manifest here. So this is the application configuration file. And you can see this one, word count service is a stateful service. It's got a target replica size of 3 and a minimum of 2. So it'll work with 2. If I kill 1, it'll still work. But the target is 3. And then I'm using a in64, unsigned 64 partition. I'm only actually using 26 numbers out of the 8 billion I could use. And I think that's what I wanted to show in the demo. So I think that's, I'll go back to the slide. And I think that's pretty much the end of it. I just have one slide left with that. So if you want the documentation and more information on Service Fabric, so that URL, ap.ns/Service Fabric. It's pretty well documented. There's books about it. It's a pretty popular service running in Windows. And I think there's a hope that it's once it runs on Linux, etc., it'll be pretty effective over there as well. And you can run containers. I mean, it's still a preview. Linux and containers wasn't preview. At the end of the day, it's kind of like Mesosphere. So I took Mesos and sort of made it run with containers. They have an orchestration, a great orchestration engine, and they can make it run with containers. Service Fabric team, we have a great orchestration engine, we can make it run with containers as well. So it's the same kind of idea. And that's it for me. Thank you. Yes? I didn't hear. It supports transactions inside a partition. So it's got API support for transactions inside the partition, which is possible. I didn't show any of the code stuff. I was trying to be. It's a 20-minute talk. Can't talk about everything. So I was trying to rush. Yeah.
So Fabric seems to do a lot of things that like what Kubernetes and Chef does. Is that?
So it's essentially a competitor, if you want, to Kubernetes. I mean, Kubernetes runs pretty well in Azure. We have a big team with Brendan Burns at running the Azure engineering team for the deployment mechanism of this, so that's one of his features he runs. So the Kubernetes will run in Azure is basically another version of a similar type of thing. The Kubernetes focuses on containers. Service Fabric is focused on different types of services and containers. It's a sort of general purpose hosting platform for services. And one of the services is a container. So it's really a high-scale production quality orchestration engine that orchestrates services, Windows services, or containers in previous examples.
So it seems that the interesting thing was the stateful services. But like Swarm or Kubernetes, like they don't really care what's in the container. They don't really know what's in the container. They just do kind of random scheduling, for better lack of term. But if you're doing something like sharding or like 64-int thing, the application has to do that too, right? So they have to like
so the client, so the application obviously is aware that it's stateful. So applications can ask, so it can essentially introspect into the cluster, into the service, into the application saying, you're stateful, because you do have to hit the right primary. It's kind of like in the early days of Cassandra, people just went to any node and then got redirected to the correct one. It's the same thing here, except you would just go directly to the correct one. You know the algorithm, you know the partitioning algorithm is at the service level. So every collection inside that service is the same partitioning algorithm. So you can just essentially ask the service, tell me where to go. And so if you go in here all the time, say node 4 all the time, and it fails, you just say, well, where to go now? And so you have to handle the failure yourself on the client side. You go to run.
So you have the concept of stateful sets in Kubernetes where you actually tell a guy your instance number 5, even though you assign a number to each person so they can figure out the sharding rules for themselves, or do you leave that to the app level to figure out?
So when I spun up this thing, I did no work. I just said deploy this service into this cluster, and here's the partitioning rules. So it says, okay, there's 13 partitions, and you want 3 replicas of each. I'm just going to use an algorithm to deploy them among the nodes. And when I did that.
There's some applications where the application itself needs to know what instance number it is, like Mongo.
Yeah, so you can, the primary is where all the work is being done. So it's kind of like Mongo's got the primary and the replicated secondaries, the primary and secondaries. This one, you don't since the active work of the application runs from the primary at a time. So that a given application is running on the primary and replica.
I'm not sure I'm asking this question. So there are databases where the database itself is running in a scale-out way. Each guy needs to know which shard he is.
Yeah, so you do know that.
And the orchestrator needs to tell him what number it is.
Exactly, so the services know which one they are. They can ask,
and the Fabric tells them.
The Fabric can tell them, they can ask the Fabric where they are.